4, section 1, talking about areas and distances. And so when I ask you to find the areas of these shapes, we can go ahead and calculate them, right? Awesome thing about geometry is finding areas. It's one of the easier things to do in geometry is find the area. So here we have a rectangle. I want to find the area of that. Or we have an area of a triangle on the second one. There. But this third shape, even though we're not given numbers, I can give you numbers. So even if I say, okay, this is 10, this is 7, this is 4, and even if I would give you this distance, say, is 3, and this distance is 3, something like that, or say this distance, say this distance is 3 and this is 2.5 or something like that. You still can't calculate the area of this, right? Because it's not a perfect rectangle or it's not a triangle. So that's the hard part about this. And so what we're doing in this chapter is finding areas, but finding areas of shapes we don't quite know. So this shape's a little bit hard to find. But what we could do is we could figure it out maybe if we extended this, because we know this full length right to this spot. We know that would create a rectangle, and so we could find the area of this whole thing. So it's 70, but then we'd have to subtract this distance, right, out of that, and then that would give us the area of the shape that we want. Or we could go ahead and maybe take the area of, say, maybe this section, or actually let's go this way maybe, or that section, and then maybe the area. Let's do it this way, actually. Let's do the area of, say, this section, and then the area of this section. So then we can have these two areas, maybe, but then it would be an underestimate, right? Because we're missing out on this area right here. So we could have an overestimate, or we could have an underestimate, this green area. And so we know somewhere our area is in the middle of those two, right? So this chapter is going to look at areas and look at distances and kind of how to figure them out. And so what it turns out on, if we have a problem like this, what we can do is that idea of doing shapes we know the areas of, mostly rectangles. So if I can take this 10 and cut it apart into evenly spaced rectangles, so maybe a rectangle like that, it doesn't really matter the size. It kind of does, because if I know that these widths are the same, I have a little bit easier way to do it. But I can just take these areas of these rectangles and then just add them up. But I'm a little overestimate there, and this one I'm a little more of an overestimate, right? Because this area right here, I'm going to have to subtract. So that's basically what we're doing, is we're taking the area of rectangles and adding them up to make up our shapes, or our areas underneath the curve. So if I want to find the area underneath the curve of y equals x squared from 0 to 2, I would go ahead and try to find the area of this by taking rectangles. So breaking this apart as rectangles. So taking this distance and breaking it apart as a rectangle. So I could create maybe a rectangle right here, and then a rectangle right here. And then that would give me the area, but it would give me the area of this, right? Which is a little bit overestimate, because this is above the graph and this is above the graph, but I only want this area from here down, right? So that'd be an overestimate. Well, if I go ahead and clear that out and maybe make more rectangles, so maybe a rectangle maybe right here, and maybe a rectangle right here, and then a rectangle right here, and a rectangle right here. Again, I still have a little bit of overestimate here and here and here and here, but it's not as much, right? And then again, if I make even more rectangles, so maybe like right here, and maybe right here, and then right here. So we can start to see, oops, that area of that I'm kind of overestimating here gets smaller and smaller and smaller. So we can see as we increase this number of rectangles that we create, and we actually kind of want those rectangles to be the same width, because then it makes it easier to go ahead and multiply and add those together, in which I'll show you how that we will do that. But if we increase these number of rectangles, we can see, so here we'll start back at 2 like I did, so we can, then it goes 3, and then we go 4, 25, so we can see that is getting more and more and more, or sorry, less and less and less overlap until we keep on increasing, so you can kind of barely see it there. As we increase all the way to 100, it kind of looks like we have no increase, but if we zoomed in, you know, we could probably see that increase in there somewhere, that overestimate. So there you go, you can kind of see it now. So see, there's still some increase. So if we keep on increasing our number of rectangles n, then we can see that overlap gets smaller and smaller and smaller. Or we can reverse that and we could do under. So everything lower than. So we have a little bit underestimate of what it might be. So that's called a lower sum and an upper sum. Lower sum meaning we are under, all our rectangles are under our graph, and an upper sum is everything above, right? But really what we're after here is right here, where we have no either overlap or underlap. So the question becomes is when we do those rectangles, that we can find the area of rectangles pretty easy, right? Length times width. But how do we know what size of rectangles we're dealing with? Well, that comes into what the number of rectangles are. So first we need to know n, the number of rectangles. So the number of rectangles that we want. And then once we have the number of rectangles we want, that's going to give us, and we know from where we start and where we want to finish, then we can see the widths of these rectangles, right? So if I take, and I have this length from 0 to 2, and I want 4 rectangles, well, that distance, I want these rectangles to be the same width, right? So I'm going to take 2 minus 0 and divide that by how many rectangles I want. So if I want 4, then they all need to be a width of 1/2, right? So I'm going to go 1/2, I'm going to go 1, I'm going to go 1.5, and I'm going to go 2. So then I have 4 rectangles. So those would be my widths, right? 1/2, 1/2, 1/2. And then how do we find out the height? So how do we find out what the heights are? Well, that would be this distance, right? And this distance, and this distance, and whatever this one is up there, right? So how do we find these heights? Well, isn't that just my y value, f of x? F of x1, f of x2, all the way to f of xi, and I'll talk about that notation in a little bit. So we plug in these x values, so 1/2, 1, so 1/2, 1, 1.5, and 2, in order to figure out what those y values are. So in order to find the height, we will take and plug in our x values. So plug in x values into the equation. The equation that they give us. Or if we do have a graph, we could look and say, okay, that's that much, and so on, right? But usually the equation that they give you. We already kind of talked about how we find the width, and that's this thing, b minus a, where you finish minus where you start, over how many rectangles you want, right? So this will change if I do this. If I want 8 rectangles, they are going to have to be 1/4 in length, so 1/4, 1/4, 1/4, 1/4. But that means my x's are no longer these, right? I would have to start at my beginning, my a, which here is 0, and then I'd have to add 1/4, add 1/4, add 1/4, add 1/4, add 1/4, add 1/4, add 1/4 until I get to my end, right? And those would be the x's that I use that I need to plug into the equation in order to get my heights, my y values. So once I have my x's, and once I have or sorry, once I have my width, right? So the first one was 1/2, and then I have my y values, right? Then I can just multiply them because those would be my rectangles. So this first one that we did, here's the rectangle, here's the rectangle, here's the rectangle, and then up top there's another rectangle up there, right? So then I can just do height times width, height times width, height times width, height times width for my 4 rectangles. 1, 2, 3, 4. Well, what do you notice about those heights? Aren't those heights all the same, 1/2? So instead of taking 1/2 times whatever the height of the first one is, plus 1/2 times the height of the second one, plus 1/2, well, that's the same as just adding up all those heights. Height 1, height 2, height 3, and so on. And then just multiplying by 1/2, right, the width. And so that's where we get to finding the areas underneath these curves. So that's kind of the process. We find our widths by this, and then we start out our A, and we just add whatever that width is. And that width is called the change in x. So we just add the change in x, and then we take that one, whatever that number is, and we just add the change in x again. So plus another change in x, which is just 2 change in x, 3 change in x, and so on to find our x's. Then we plug those in order to find our y values. So what you'll notice on these problems like this is they'll usually ask you to find the area mostly 3 ways. We have a left, we have a right, and we have a midpoint. So let's go ahead and do this example from the left side, since our rectangles at the top are already from the left. So we can see that here we have our equation y equals x squared, and we want to find the area underneath this, bounded by the y and x axis. So depending on how many rectangles we have, we go ahead and want 4 here, so that's where we do our change in x. So change in x equals to 1/2. And since we're doing it from the left, so this would be, the notation would be left with 4 rectangles. So that's going to be taking up all these rectangles, the 4 of them, and adding them together. But it's from the left-hand side. So there's a little bit of difference, left-hand, right-hand, and midpoint. So how you figure that out is the left-hand side means we actually start our rectangles from the left. And so these ones would be a little bit different from what we're doing. So left-hand side means we start from the very left x value. So the very left x value is our A. Right, so we're actually going to create a rectangle starting at our first A. So here's the rectangle. Boom, it's just a straight line, horizontal line, which means our height of that would be 0. And then I do the next rectangle. So the next rectangle would be adding, we add our change in x to that, which is 1/2. So that would be at 1/2. So there's our x, and here's what it looks like our rectangle is. So that's what our rectangle looks like. And then our second x would be adding another 1/2 to that, so that's at 1. And then I add another 1/2, so that's 1.5, and then another 1/2, which would get me to 2. So that makes the span from 0 to 2. But notice that I already started at 0, so there's one rectangle, and then I went to 1/2, there's another rectangle, and then I go from 1, so here's another one. Oops, let me erase that. And now I start at 1.5, and notice that that is my 4th rectangle. So I'm actually not going to have any more rectangle because my rectangle is right here, L4, number of rectangles right there. So that's what my rectangles look like, and you notice that I'm actually under the graph here, 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 and here. So it's an underestimate, and it's actually a lower sum because all my rectangles are underneath the curve. So it's a lower sum. Okay, so now what I'm going to do is I'm going to find the heights of all these. So we already talked about this. How do we find the heights? By plugging this into our function. So I plug 1/2 into my function, I get 1/4. I plug in 1, I get 1. And this graph's a little bit different than the actual curve, so don't pay attention to these y numbers. They're not relevant. We're using y equals x squared. I plug in 1.5, so that's 9/4. And then I do not have to plug in 2 because my first y value was 0. Okay. And so this curve is a little bit off. It should actually look something like this. And it goes up from there. That was probably pretty bad too. Because this graph behind it's not the y equals x squared. Okay, so there's what kind of my graph looks like. Those are my rectangles. And so now I'm going to add up the areas. Well, the areas, like I said before, is just taking your width 1/2 timesing by each height. Well, might as well just add up your heights. So 0, 1/4, 1, and 9/2. So I can common denominators. 4/4 and 18/4. If you want to change them to decimals, that's fine. So I add up all these. So I get 23/4. Right, so I get 23/4. So that's my heights, 23/4. Now I have to times them by my widths. So the long way of writing this would be 1/2 times 0 plus 1/4 plus 1 plus 9/2, and then times it by 1/2. So that is, what did I say? 23/4 times 1/2 is 23/8. So the left-handed sum with 4 rectangles is 23/4, or 23/8. Sorry, 2 times 4 is 8. So that's the left-handed one. So it could all switch if I do the right-handed one. So the right-handed one, I do not start at A anymore. I don't start at A because I start from the very right-hand side. So I'm actually going to start at 2 from the B and then go backwards. So it's going to go all the way up, and then it's going to go 1/2 this way. So 1/2 minus 2 is 1.5. So I'm still using that 1.5. It's just I'm going to start with 2, use 1.5, use 1, and then use 1/2. Okay, so here are my rectangles. So those are my rectangles, and you kind of see all these ones, even though that graph that's on that line is not accurate. I'm an overestimate here. Here I'm an overestimate, so that's an upper sum because they're all above. All rectangles are above. So I'm using those same x's. So I'm going to use those same y's, right? So this is still 9 9/2. This one would be 4. This one would be 1. Oops. This would be 1, and this would be 1/4. Right? Would be my heights of those. Okay, so instead of using 0 and starting at 0, I'm going to start at 4 for my y values here. So the right-handed, I don't know why it's doing that, right-handed with 4 rectangles is equal to 1/2. Ooh, sorry about that. 1/2 times 1/4 plus 1 plus 9/2 plus 4. So here you could do decimals if you want. So we got 4.5 for 9/2, and we got 0.25. And then we have 1, 4, so that's 5. That's 9, 9.75, or 9 3/4. And then we're going to times that by 1/2. So we times that by 1/2. We get 9.75 over 2, whatever that is. So that's our right-handed one with 4. It's kind of catching there. Sorry about that. So that's kind of how you do these. The last one, the one with M, that's midpoint. So this one's a little bit trickier. You have to find the middle and find the height from that. So find the middle and the height from that. So this is where it's kind of messing up your x's. It's still, you're changing x. Your change in x is still 1/2. So you still have these x's, but now you got to find the middle of those x's. So I got to take 0 and 1/2, find the middle, 1/4. 1/2 and 1, find the middle of that one, 0.75, and so on. So I got to find the middles, and then I got to plug those middles into my equation to find the heights of those. Now what you'll notice about this is that when you look at these rectangles, you have a little bit above and a little bit below. Okay, and then a little bit above, a little bit below, a little bit above, a little bit below. So these ones would look more something like this. These would be these rectangles. So those would be the 4 rectangles, like that. So there's some above and some below. So this is not an upper limit or a lower limit, because not all of them are above or not all of them are below. And then the tricky thing is taking the middles and plugging those into your y value. But your width of all these is still 1/2. The width is still 1/2. Okay, so the midpoint, that's a little trickier. So let me explain and I'll be done with this video, because it's kind of long. Upper sum and lower sum. So sometimes when you do all left-handed ones, so here's my a and here's my b of this function, and so here's the left-handed ones going something like that, and then from here, so you notice that that's a little bit above and a little bit below, right? So that's not going to be a lower sum or an upper sum. So what happens is, in order to figure out a pure upper sum or pure lower sum, sometimes you might have to mix right-handed ones and left-handed ones in order to get an upper sum. And in order to get the lower sum, you might have to mix them. So as you look at it, as you look at a graph, it might switch. Okay, so I might take so this one, for instance, this is a left, so I'm going to take a left here for an upper sum, but I'm going to take the right on this rectangle to continue with the upper sum, and this one, so another right, another right, another right, and this one I want to take a left with an upper sum and a left. So the upper sum would contain a left, a right rectangle. So these R's and L's are based off of just a pure rectangle, just one rectangle for each of them. So it would contain a multiples of left and right-handed sides, and the lower sum would be the same. I would take a left for this one, a right, and then a left, and then a left, a right, and a right for a lower sum. Okay, so if it's after pure upper and pure lower, that means you could take some from the left rectangles, some from the right rectangles. It might be a mixture there. Okay, and then in the next video, it's still a little part of 4.1, but it's about the sigma notation. So instead of writing 1/2 times 0 plus 1/4 plus, 1 plus 9/2, right? And because if I have more rectangles, this number is going to increase, right? Because these will always be however many n I have, right? So if I have n to the 6, I should have 6 numbers here, 6 y values here, times by my change in x. So if I have 10, I'm going to have 10 numbers there. So there's a different way that we can write this, and I'll talk about it in the next video. Okay, sorry, real quick, we are actually not done with this video. So we want to talk about distance real quick, because it was area and distance. So distance is really the same thing. We can use this to calculate distance as well. So distance, here our distance, in order to do it, our x's would be in time, and our y values would just be velocity. But it's the same type of problem. So here I need to find the change in x between these two values, that they're all the same, and then my y's would be my velocity. But here I just need to calculate, make sure they're in the same unit. So this is in seconds and this is an hour, so I would need to convert this or this to the same units, right? But the distance is still the same, so we can still deal the same type of problems, add our y values together, which is our velocity, and then multiply that by our change in x, which is just our change in time. But it still has to do with the same thing. The left-handed one just starts from the farthest to the left, and the right-handed one starts from the farthest to the right. So I would use this y value to start on the right, and from the left I would use this y value to start once I change my units. Okay, so really the distance problem is still the same. We can use this in a lot of different things other than finding distance and finding areas. Sometimes it has to do with force or volume, but there's different applications that you can use for this. Okay, now we're done.